talk about Chapter 1, Section 5, Rewriting Equations and Formulas. So for vocabulary, we're going to talk about literal equations. A literal equation is an equation that has two or more variables. So for example, here we have the equation 3y plus 9x equals to 9. And in this case, you can see here that there is more than one variable, and we can show that it is x and y. So here we have two variables. That's why we call this a literal equation. And in the other equation, we have y, x, and z. And so this one shows three different variables. And because of that, we call this a literal equation as well. So we're going to talk about the steps to solving literal equations. So I'm going to share my screen so that we can look at the iPad for a moment. Cool. Okay, so the question is asking us to solve the literal equation 3y plus 4x equals to 9 for y. Now, when you get an equation like this, they will tell you what they want you to identify. In this case, they said that they want us to identify the y. So I see that y is here. That means that I want to isolate the y. So I'm going to write down the equation 3y plus 4x equals to 9. And I'm going to highlight my y here. And the reason why I want to highlight it is because I want to know what I need to move to the other side. So let me write down that cut line again. Now anything on the side of the y, I want to move to the right side of my equation. And so that means that I want to move that 3 to the other side. I also want to move the plus and 4x to the other side as well. Anything that is next to the y, I want to move to the other side, pretty much. And by doing this, I am isolating my y. So I'm going to start off by looking at the positive 4x. What I want to do is subtract 4x to both sides, since I'm doing the opposite operation. When I do that, I get here 3y, 3y, and 4x minus 4x just gives me 0. And that equals to 9 plus 4x. Because 9 is not a like term with 4x, I can't combine it together. So I'm just going to write down 9 plus 4x. Okay, so now I am left with 3y equaling to 9 plus 4x. The last thing that I want to do is move that 3 to the other side. I know that whenever I see that a number is next to a variable, or a variable is next to a variable, there is still that imaginary multiplication sign in between them. So because there's an imaginary multiplication sign, I want to do the opposite operation and divide 3 to both sides. So when I divide 3 to both sides, I'm left with y equaling to 9 over 3 plus 4 over 3x. Okay. And so I get as my answer y equals to 9 over 3 gives me 3 plus 4 over 3x. And now that I have isolated the y, there's nothing on the same side of that y that I need to move, then I can say that this is my answer. My answer would be y equals to 3 plus 4 over 3x. Let's try out another one. We have here solve the literal equation y equals to 3x plus 5xz for the letter x, or the variable x. So I'm going to do the same thing where I write down the equation first. Plus 5xz. And I'm going to highlight again the x because right here, those are the variables that I want to have isolated. Now, this one's a little different because I see that there are two x's, and I just want to combine them together to just have only one x instead of having two. So the way that I can do that is by factoring. Now, if you remember on this side, let's do a little review. Okay, so over here, if I had x times a plus b, the way that I answer this usually is by distributing the x to both the a and the b, and so I'm left with xa plus xb. Now, this is called the distribution property, right? The thing that I want to do is I want to do the opposite of distribution property, and that would be factoring. So when I'm factoring, I'm usually given something like xa plus xb instead. And because they both have x in their expression, what I want to do is I want to factor it out. So I'm going to divide x to both sides. And so I'm left with x parentheses a plus b. So as you can see here, it's literally the same thing as the distribution property, but in the opposite format. Normally, we have the parentheses come in first and then distribute the expression. But in this case, the expression is already distributed, and I want to create the parentheses and by factoring out the x and moving that x to the side. Okay, so I want to do the same exact thing for this expression here. I know that they both have x, which means that I could factor it out. So I'm going to divide x to both terms. When I divide x to both terms, I'm left with x parenthesis 3 plus 5z in the end. And so I get y equals to x parentheses 3 plus 5z. Now, again, since x is next to the parentheses, that means we still have that imaginary multiplication sign there. So instead of multiplying, I can divide on both sides. Divide that 3 plus 5z. Divide 3 plus 5z. And that cancels out this right here. And so I am left with y equaling to 3 plus 5z in the end. And that equals to x. So now that I have just one x, this would be my answer. Okay. So why do we need to know about this? What makes this information so important? If I go back here, here are some common equations that use literal equations. One of them that we talk about is temperature. So temperature here has the formula C equals to 5 over 9 parentheses Fahrenheit minus 32. So normally we use this to convert the Fahrenheit into Celsius. We also use it when discussing money, when we have something like the formula interest equaling to principal times the rate, annual interest rate times the time here. And then the other one is also speed, where it's distance equals to rate times time. So what I want to do is I want to ask the question here. Let's say that I know what the Celsius is, but I don't know what my Fahrenheit is. So what would be the formula that I would use instead? So suppose I wanted to convert Celsius into Fahrenheit. Fahrenheit. What would the formula be? So I'll give you time to answer this question. Okay. So let's try it out together then. And let me clear this image. Okay. So if I wanted to convert Celsius into Fahrenheit, what would my formula be? So the formula that we do know right now is that if we have Celsius, that equals to, let me get the formula out one more time, 5/9 times Fahrenheit minus 32. Cool. So this formula is converting Fahrenheit into Celsius. What I want to do is I want to convert Celsius into Fahrenheit, which is the opposite. So that means that I want to identify or isolate the F instead. Right now we have isolated the C, but I want to isolate the Fahrenheit instead. So how do I do that? A lot of people start off by distributing, but I don't want to do that because that just brings the 5/9 closer to the F, and I don't want to do that. What I want to do is I want to get the 5/9 away from the F. So instead of distributing, I'm going to divide because I know that 5/9 is multiplying with the parentheses here. And so I'm going to divide 5/9 to both sides. And when I divide, let me make that nicer looking over here. So divide 5/9. Now when I look at that, I see that this cancels out nicely, but over here we get this ugly looking equation or expression. And it makes it look confusing and I don't like it, so I'm going to make it look a little nicer. I know that C is dividing by the 5/9. Whenever we write the equation down, the top number is always going to be on the left side and the bottom number always goes to the right. So that looks a little bit more appealing than the other expression here. This one was just ugly looking. And so we get Fahrenheit minus 32. Okay. Now when we are working with fractions, it's a little different whenever we divide them. The first thing that we need to change is the division sign. The division sign always turns into multiplication. And we also know that our fraction needs to be flipped, which means that we get 9/5 instead of 5/9. And then the C just stays the same. That one doesn't matter. So we get Fahrenheit minus 32. So when we're multiplying this, I know that C in a whole number would be equal to C/9, because if we had, for example, 6, we could also change this into a fraction by writing 6/1 or 7, or maybe not 7. Let's try like 100, right? That in a fraction would be 100/1. So any number, whole number at least, can turn into a number over 1. And it still equals the same exact thing. So all of these here, they all equal to each other. So we could just change them into fractions if we wanted to. So that's why here, C, we can just change that into C/1. So C times 9 gives me 9C. 1 times 5 gives me 5. And that equals to the Fahrenheit minus 32. Last thing, since F is subtracting with the 32, I could do the opposite and add 32 to both sides. So when I add 32 to both sides, I see here that these are not like terms because this one has a C, this one does not have a C, so we can't combine them. That means I just have to move the 32 to the side, so I'm going to be left with 9C/5 plus 32 equals to the Fahrenheit. So now I have, let's say that I knew what the Celsius degree was. Oops. Oh, that did not work out. Okay. Let's say I knew what the Celsius degree was. I can convert it now to the Fahrenheit with this formula here. And so this would be my answer in the end. Okay. Let's look at money. Alright, so if we're talking about money, I equals to PRT is talking about simple interest. Now, simple interest can be used to calculate monthly loans or deposits. So, for example, you could have a monthly loan on a car because you don't want to pay the entire amount of a car up in person. You want to create these like monthly deposits. Or you could also have these monthly deposits that you make to save money, that type of thing. Principal, so this P, it is the original sum of money that you deposit into an account. So for example, if you have a bank account and you started off by depositing $500. Now the annual interest rate tells you how much interest you owe or make on a yearly basis. So sometimes you'll get these advertisements by companies saying, by depositing money into our company, you will earn 4% simple interest. That means that on a yearly basis, they will multiply 0.04 with the amount that you deposited and add that into your account. What is interest? Interest is represents a fee or that you pay or a loan or income you earn on a deposit. So after 3 years of leaving your money into the account, you now earn $162.50 in interest. So like if you start off with $500 and then after 3 years you get $162.50, all of a sudden now you have $662.50 in your account. And so you didn't do that you just did that by leaving that $500 into your account for 3 years, and automatically it increases the sum of money. So let's try it out. Let's say, for example, suppose that you see a company and they told you if you deposit money into our account, you earn 4% simple interest. So over here, what would the simple interest represent? Would it represent your principal, your annual interest rate, your interest, or your times? In this case, it would represent your annual interest rate. And so that would be your R. And then it says here you deposited $3,000 or $3,500. So what would this $3,500 represent? This should represent your P. And the reason why it's because it's the first amount that you deposited into your account. And then after 4 years of leaving your money into the account, and so this 4 years should represent your T, because that is the amount of time that you took. So this is time. And then the last one is you earned $450 in interest. Now this one will last be your I, your interest here. So is this amount correct, or are you getting gypped? So let's try it out. Let me clear this and write it down here. Over here we know that our R was 4%. We know that our P is our $3,500. Our T is 4 years, and then we said our I is $400 or $450 there. Okay. So let's look at our rate to see our annual interest rate to see if that's correct. So let's make a question mark there because we don't know if it's correct or not. So our formula is I equals to P. That's not a P. P. That looks nicer. I equals to PRT. And let's say that I want to look at and focus on my R. So how could I create, or what formula would it be if I wanted to change my formula focusing on my R? So isolating my R out instead. Okay, so over here what I could do is divide the P and the T to both sides. And so I'm left with I divided by PT equals to R. Okay. So I know that my I equals to $450. My P equal to 3,500, and then my T equal to 4 years. So it's for 4. And so if I were to calculate all of this up, 450 divided by 3,500 times 4, that gives me 0.032, and that can be rounded up to 0.03. So if I wanted to change this into a percentage, all I need to do is move the decimal to the right twice, and so I get 3%. So based off of the information that's provided here, right, I found that they're actually only giving me 3% annual interest rate, even though they told me that they were going to give me 4% simple interest rate. So that means that if they're asking us, are you getting gypped or are you getting scammed? The answer is yes, because rather than getting that 4%, they're actually giving us only 3%. Okay. So this is just a few examples of how literal equations can be used in the real world. Let me know if you have any questions. If you don't, that's great. Good luck.